Every challenge question from the textbook, part 13. This is chapter 11. I think it's the vectors, is it? It is, good. So if we place, they want me to show the area is given by this. If we place a coordinate grid over the top, then if this vector is pi plus qj, that means it's p across and q up, which means I can describe this coordinate as p comma q. And likewise here is going to be r comma s. And then this one up here is going to be p comma q plus r on the x coordinate plus s on the y coordinate. So that's going to be p plus r, q plus s. And I think that's basically all I need. I can now do some stuff. If I surround the entire thing with a box like this, the area of the entire box is p plus r times q plus s, which is that. And now if I do some further lines like this, I think I can work out the area of this triangle is, well, this length here is q plus s. This length here is r by this definition here. So this area is a half times r times q plus s. And this area here, well, this length here is, the height is q plus s, and you're going to want to take away this s. So that's going to be a height of q. So this length here is q, and then this length, of course, is p plus r. So this area is a half times q plus p plus r. By some symmetry, you can notice that this area is the same as this one, and this one is the same as this one. If you didn't want to use symmetry, you can just verify this is still q, this is still p plus r, and you get the same thing here as likewise here. So, of course, the area of the thing we want is just this thing here, the total box. Take away two of these triangles, which is just getting rid of the half, and taking away two of those triangles, again, just get rid of the half. And now if you do some expanding out and taking the things away and cancelling out, you end up with what they wanted us to get. This question here says we've got a line like this. Let's sketch it. So y-intercept of 6 when you divide by 2, gradient of minus 3 over 2. If you put in y as 0, you find x is 4, I believe, like this. Now, we've got a point on this line, b, that's root 13 away from the origin. So this distance here is root 13. So if we call b x comma y, just the coordinate x, y, I'm basically just completely ignoring vectors entirely. I'm just doing some coordinate stuff. This distance here is x, this distance here is y, which means x squared plus y squared equals root 13 squared, which is, of course, just 13. But also, y equals 6 minus 3 over 2x, as we said. And we've just turned this entire question into just a quadratic simultaneous equation question that you would get in just a regular question of chapter 3. Like, that's all I've done here. So substitute this y into here, do some expanding out. I bothered to times everything by 4, I don't know why, and then move the 52 over. If you plug that in a calculator, you get two answers of these. And if you put those two things in a calculator into here, you'll get these two things here. If you desperately want to, you could try and factorize this, but or even complete the square, but yeah, I don't really care. So our answers in vector form are 2i plus 3j, or this I plus this j. And those would be our two things done. Next one is kind of cool. We've got this parallelogram here, and it's going to ask us a bunch of questions about this. So p to x. Now, what I'm first going to do is say p to n is a half of b, because n is the midpoint, and likewise r to m is a half of a, because that's the midpoint, and these are parallel vectors, so they're the same. Now, p to x, therefore, firstly, I'll say O to n is just a plus a half b, and then therefore O to x is just some amount of a plus a half b. I'll just call it k amount of that, where k is just some number between 0 and 1, which means p to x is minus a plus O to x, the thing I just found. So p to x is minus a plus that. And then, of course, we can group the a's together to make k minus 1 a's and plus a half k b's. And that's p to x, which is actually the second thing they want me to do. So let's do the first thing. And to do that, of course, I'll just go the other way around. So p to x, I'll just go instead. I'll talk about p to r first, this one here. Now, p to r is clearly minus a plus b. And so p to x is just some amount of p to r, because it's just a smaller amount of the whole thing. So just call that j, because that's what they've done, and expand that out, and you get what they wanted there. So that's a and b done. Explain why we must satisfy these. Well, these two things, look here, they represent the same vector p to x. And so therefore, they're the same. And so therefore, the a's need to match the a part of the vector, and the b's need to match. This is what's called comparing coefficients. So therefore, because these are the same vector, that means minus j equals k minus 1, and j equals a half k, which is what they wanted here. We can solve this very easily. This is minus a half k is minus j, so just put that there. Add a half k to both sides, add 1 to both sides, divide by whatever it is, you get k as this. Halve it, you get j as this. Deduce that ON and OM divide into three equal parts. So just say this is into three equal parts. You already know, because you found J as a third, that P2X is a third of this thing. Just going to get rid of that. Apologies. Okay, that's fine. So this is definitely a third. Is this also in thirds? Well, there are probably better ways to argue this, but all that I noticed and just gave up at that point on was if you just do exactly the same thing you did here, not with this top section, but with this bottom section down here, the only thing that changes is this bit here is B plus a half A instead of A plus a half B. So you just, in your head maybe, because I can't be bothered to type it, just swap the B and the A over, and this ends up being a B, and this ends up being an A. But then when you compare it with this, that doesn't make a difference, right? Like you're going to end up with the same two equations down to a minus, which just doesn't end up mattering. And you end up with the same two answers, and then, of course, that ends up making this a third of A plus a third of B, or minus a third of A plus a third of B, which of course means that these three things are in three equal segments. There are probably better ways to argue that, but as soon as I spotted that, I just thought, I'm not going to bother typing that up. I'll just explain that on the fly, and that'll do. So yeah, sure. Good. The point B, yeah, this question is the same as the question we did before. I don't know. I don't know why of the four challenge questions in this chapter, they just wrote the same question twice. Was there really nothing else they could think of? But B is this distance away. I'm just going to call it XY. I'm literally going to do exactly the same thing. It ends up being the same thing, but more annoying because there are more fractions. But I was kind of fed up at this point, so I just put it straight in the calculator and pretended to do any work, and just got immediately these answers, and then put them in the calculator to get the Y answers, and you end up with your two vectors, and that's the whole question. That's the end of the chapter, so I'll see you next time.